Hello, everyone. I'm going to talk to you about how to manage confidential data in a context of a public blockchain. So, my name is Draltan Marin. I'm the CTO of UnicornBay. And I hope you enjoyed the conference by NewCipher, because I'm going to keep talking about proxy encryption, just in a different perspective. I'm going to present a use case, a business use case where we are tracking confidential data and how we manage to protect that data, to give and control access on who can see the data. So just to introduce you to our use case, UnicornBay is a blockchain solution for the asset management industry. So what we're doing, we're tracking trades that asset management people will be doing on a day-to-day basis. And to explain you why this is interesting, imagine you're an investor and you have a lot of money, you want to invest that, and you want someone to take care of these investments. So you're looking for an asset manager, but when you're comparing your different options, all you can use to choose and to select who will be handling your money are performance metrics of asset managers or track records. But the thing is that in classical investments, these track records and performance metrics come from the asset manager themselves. So you don't know if you can trust what they are saying. If they tell a return rate of 40% a year or so on, you have no way to know if it's true or not. So in order to make a safe decision, in general, an investor will go to a big player because it's a big name and because it's safe. So that means that the smaller players, the smaller asset managers, it's very difficult for them to access the market, right? So the idea is that we're going to track what asset managers are doing, and from that, compute key indicators of their performance, of their returns, and indicators that you can use and you can trust. And as an investor, you can choose your asset manager based on actual numbers that you can trust, right? So this makes better informed decisions for investors, and for asset managers, it opens a larger market of investors, right? So the kind of data we're tracking is day-to-day trading data. So every time an asset manager will be doing a trading operations, buying or selling a stock or bonds or whatever, they will put that data to a blockchain. Okay? So we can follow their portfolio strategies. We can know the composition of an investor portfolio. But all these are very confidential data. No one wants to make this data public, right? At the same time, we want to put that in a blockchain so we can build trust, but the data is very sensitive for our market. So we need to put that in a blockchain because we need to know that when we are computing performance indicators, we're considering all the data, not just the gains that the asset manager made, but also the losses, right? So from a technical standpoint, what we want to guarantee is data integrity, access to this data, and access control to this data, and doing so in a way that's secure, right? So the main two options we were considering for our solution was, okay, either a private blockchain where we will be keeping a control on who can access this blockchain, or a public blockchain where all the data is available to everyone, but we will publish only encrypted data. So we will manage with this encryption who can actually see the data, right? Just on that, a little note on scalability, because we're saying we're putting a lot of data on a blockchain. We are working on the Ethereum network, and as you all know, there are scalability issues, mainly on performance. This is time to confirmation, and cost of writing data, mainly. And for our case, what we are going to write, it's a huge amount of data in blockchain standards, right? So we explore different solutions of scalability. We know there are channels, there is Plasma, there is sharding. What we're going to do is we're going to use a side chain where we're going to dedicate a secondary chain for asset managers so they can write data on a day-to-day basis, and we're syncing that to the main chain periodically. So the large amount of data will remain in this secondary chain, and then we will publish only a small amount of data to the main chain, mainly key performance indicator. So that being said, we are saying we're publishing encrypted data, but then how can we do to use this data, right? We have two main problems here. One is, how can we do computations on this data and guarantee that these computations are correct? And the other is how we can control the access, who can go and see the actual data. So for the first part, we're using secure multi-party computation. This is with the Enigma project. For those who are not familiar with that, I'm not going very deep into that because it's not the subject of the talk, but we are separating the computation of metrics into very atomic pieces, very atomic chunks of calculation that we are distributing to a network of nodes that will perform computations and then aggregate their final result. So we are able to compute metrics where no one had at no point access to the full data. At all time, nodes are just accessing very little pieces of meaningless data and performing very little computations. So, however, we can guarantee that the final result corresponds to the data we are using in the first place. The second point is about how we can control dynamically who can access the encrypted data. And there is NewCipher to the rescue. So, in a classical encryption scenario, Alice is sending a message to Bob, right? And both Alice and Bob have private and public keys. Bob sends the public key, Alice encrypts the data, and Bob gets the message and can decrypt using the private key, right? But in this scenario, Alice knows she's sending a message to Bob, right? So what happens when Alice doesn't know who she's sending a message to, right? This is exactly our use case. Investors are asset managers are going to input data in a blockchain, but they don't know who will need to access this data later on, right? So it can be new investors, subscribers to their portfolio strategies. The thing is, at the moment of posting the data, we don't know who this will be. Say, instead of being Bob, is Charlie, who's requesting access to the data. So the very naive version would be, okay, how to do? We could send a private key to Charlie, but we know sharing a private key is never a good idea. We could decrypt the data and re-encrypt it again for Charlie, but then Charlie would know that is the same data or not that Alice inputted in the first place. So this is where we're using proxy encryption. The thing is, Alice will publish encrypted data to the blockchain. Then Charlie requests access. This is an investor or a subscriber asking to follow the strategy of the asset manager. And then Alice will emit a proxy encryption key, a re-encryption key, and it will this key will be sent to the proxy that will perform the re-encryption. So the proxy will take the encrypted message, the original encrypted message that's published in the blockchain, and produce a new encrypted message. And as I said before, the proxy never knows what is the contents of this message, right? So with this, we are able to track trading data into a blockchain, and then the investor can be sure that the data he's receiving is coming from this blockchain through a proxy and encrypted for him in a way that we can track the whole chain. So the investor can be sure that he's accessing the actual same data that the asset manager originally posted, right? We can do that in a way that the investor has access to all the data in a given scope, like could be a time span, or could be for some of the asset manager strategies or so on. But on this scope, the investor has access to everything and can check all gain and losses and all trading operations, right? So that's good for controlling who can access the data. But what about revoking access? So the thing is, we are producing re-encryption keys that can be revoked. And these re-encryption keys will be split, as I said before, over different nodes, and we can ask for revocal of these re-encryption keys. And that gives us the flexibility to grant access and to revoke access later on, right? When an investor is no longer working with an asset manager, the asset manager can say, OK, I can revoke your key, so you will no longer keep following my strategies, right? So just to put all that together, we're creating a system where we're building trust between investors and asset managers, where we can compute key metrics that can be trusted. This is with the Enigma solution. Then that we can guarantee that confidential data remains private and controlled, and that we can manage to grant and revoke access to that data, and all that in a context of a public blockchain with cryptography solutions. So thank you for listening. I'll be glad to answer any questions you have. And you can contact either me or Dennis, the CEO of UnicornBay. And thank you.